Hello, my dear children. Today we are going to start chapter 2, second chapter, that is polynomials. Okay, exercise 2.1. In this exercise, we discuss the following points. The first point, these are the concepts or points we discuss for the exercise 1.2.1. First point is polynomial. What is meant by a polynomial? And second point, polynomial in one variable. Okay, my dear children. And the third point, third concept is terms of a polynomial. What are the terms of a polynomial? And the fourth point, coefficient of terms of a polynomial. Okay, my dear children. Fifth point, zero polynomial. Okay, sixth point, types of polynomials based on number of terms. There are different types of classification of polynomials. Based on number of terms is one classification of polynomials, and types of polynomials based on the degree of the polynomial, that is another classification. Seventh point, degree of a polynomial. What is meant by degree of a polynomial? Next, eighth point, degree of a non-zero constant polynomial. What is the degree of a non-zero constant polynomial? And ninth point, types or classification of polynomials based on the degree of the polynomial. Okay, my children, we discuss these points in this exercise 2.1. Okay, my children, right. And next point, general form of a polynomial of degree n. And 11th point, degree of a zero polynomial. What is the degree of a zero polynomial? We discuss all these 11 points for exercise 2.1. Okay, my dear children? Right. Now come to the first point, polynomial. What is meant by a polynomial? It is a particular type of algebraic expression in which the exponent of the variable in every term of the algebraic expression is a non-negative integer. Remember this point. The exponent of the variable in every term of the algebraic expression must be a non-negative integer. Only that type of algebraic expressions are called polynomials. Let us take an example to understand this concept clearly. See example, minus 3x square plus 5x minus y power 5. It is a polynomial because how many terms are there? 3 terms are there. Minus 3x square is one term, plus 5x is second term, minus 5 to y to the power of 5 is the third term. In the first term, what is the variable? X. What is the exponent of the variable x? 2. It is a non-negative integer. Now come to the second term. What is the variable? X. What is the exponent of the variable x here? 1. It is also a non-negative integer. Now come to the third term. What is the variable here? Y. What is the exponent of y? 5. It is also a non-negative integer. Therefore, this algebraic expression is said to be a polynomial. Is it clear, my dear children? Right. Now let us take another example. X power 10 minus 1 by 5x plus 7 by y square. This is an algebraic expression, but it is not a polynomial because the exponent of y in the term, in this term, in the third term, in the third term, in the third term is minus 2, which is not a non-negative integer. Here, what is the first term? Here also there are 3 terms. That is, the first term is x power 10 second term is minus 1 by 5x, and the third term is 7 by y square. What is the variable in the first term? X. What is the exponent of x here? 10. It is a non-negative integer. Now come to the second term. What is the second term? Minus 1 by 5x. What is the variable here? X. What is the exponent of x here? 1. No power, no integer means it is a 1. It is considered as a 1. Now come to the third term. What is the third term? 7 by y square. 7 by y square. Here the exponent of y is minus 2, because here 7 by y square can be written as 7 into 1 by y square, that is equal to 7 into 1 by y square can be written as y power minus 2. Okay, my dear children. Now, what is the exponent of y here? Minus 2. It is not a non-negative integer. It is a negative integer. That is why this expression is only an algebraic expression, but it is not a polynomial. Understood the concept of a polynomial, my dear children? Right. Now let us take another example. Minus 4x cube plus 2 by root x. This is an algebraic expression, but it is not a polynomial, because the exponent of the variable x in the second term is minus 1 by 2. See here, because 2 by root x can be written as 2 into 1 by root x, that is equal to 2 into 1 by root x is can be written as x power 1 by 2. Do you remember this one point, my dear children? Right. That is equal to 2 into 1 by x power 1 by 2 can be written as x power minus 1 by 2. Now, what is the exponent of x here? Minus 1 by 2. It is not a non-negative integer. It is a negative rational number. Okay, my dear children? Right. Now, discuss the second point. We discussed the second point. What is the second point? Polynomials in one variable. Polynomials in one variable. We use the letters x, y, z, etc. to denote variables. In earlier classes, you have learnt this point. To denote variables, in general, we use the letters x, y, z, etc. We write constants as a, small letter a, comma, small letter b, comma, small letter c, etc. To denote constants, remember these points. A, B, C, small letters A, B, C are used to denote constants. However, there is a difference between a letter denoting a constant and a letter denoting a variable. There is a difference. X, Y, Z always denote variables, whereas A, B, C, D, etc. denote constants. The values of the constant remain the same throughout a particular situation. That is, the values of the constant do not change in a given problem, but the value of a variable can keep changing. You know, variable means unknown value. It changes from problem to problem. Whereas constant, it is a fixed quantity. It does not change its value throughout the situation. The value of the constant does not change. Understood this point, my dear children? Right. In the polynomial x square plus 2x, the expressions x square and 2x are called terms of the polynomial. These are called terms of the polynomial. How many terms are there? Two terms. X square is one term and 2x is a second term. Similarly, the polynomial 3y square plus 5y minus 7 has three terms. Namely, what is the first term? 3y square What is the second term? 5y. And what is the third term? Minus 7. Is it clear, my dear children, how to identify the terms of a polynomial? Next, the terms of the polynomial minus x cube plus 4x square plus 7x minus 2 are. How many terms are there in this polynomial? 4 terms. The first term is minus x cube, and the second term is 4x square, and the third term is 7x, and the last term is minus 2. Is it clear, my dear children? Right. In the polynomial x square plus 2x, let us take this polynomial. The coefficient of x square is 1. Before this variable, what is the number here? Nothing. So we consider there is a 1. There is no number before a variable. We consider it as a 1. So coefficient of x square is 1. And the coefficient of x is 2. Before this variable x, what is the number here? 2 is there. So 2 is called the coefficient of x. The first term is called x square term. In this polynomial, this first term is called x square term, and the second term is called x term. What is the second term called? X term. What is the first term called? X square term. Is it clear, my dear children? Right. So the polynomials which are taken as examples, they are all the polynomials in one variable, because if you observe the polynomials, we have used only one variable, letter x only. Throughout the polynomial, we used only one letter, that is x. It may be x cube, it may be x square, it may be x. But throughout the polynomial, we used only one letter, only one variable. That is why they are said to be polynomials in one variable. Is it clear, my dear children? Right. Now come to the next point, constant polynomial. What is meant by a constant polynomial? See here, 2. 2 is also a polynomial. In fact, 2, minus 5, minus 3 by 7 are all examples of constant polynomials. Here no variable is there. Only constants are given. All are constants only. So that is why these are called constant polynomials. Here no variable is there. Is it clear, my dear children? Only one term. 2 is one term. In that polynomial, only one term is there. Minus 5, it is also a polynomial having one and only term, that is minus 5. Similarly, minus 3 by 7, it is also a polynomial having one and only one term, that is minus 3 by 7. No variables are used here. That is why these polynomials are called constant polynomials. Is it clear, my dear children? Right. Now come to the next point, that is zero polynomial. The constant polynomial 0 is called zero polynomial. This is a particular case. 0 is also a constant, but it is not said to be constant polynomial. It is specially called zero polynomial. If it is 0, then the polynomial is called zero polynomial. It is not a constant polynomial. Non-zero number, whatever the number, non-zero number, they are said to be constant polynomials. Is it clear, my dear children, the difference between constant polynomial and zero polynomial? Zero polynomial means 0 only, only one term, that too 0 only. That is called zero polynomial. Whereas constant polynomial means any number, any non-zero number, any non-zero number is called constant polynomial. Okay, my dear children? Right. Now come to the next point, that is types of classification of polynomials based on number of terms in the polynomial. This is one classification, one type of polynomials based on the number of terms in the polynomial. Let us take some examples. See here, I wrote here polynomial, here number of terms in the polynomial, here name of the polynomial. If you take this first example, 2x, how many terms are there? only one term, only one term. So this polynomial is called monomial. Mono means one and only one term is there. That is why this polynomial is called monomial. Now come to the, understood this point, my dear children? Right. Now come to second example. Minus 5x square minus 5 by 3x. How many terms are there? This polynomial has only two terms. Only two terms. So this polynomial is called binomial. Bi means two. Is it clear, my dear children? Right. Now come to the third example. 3 minus 2y square plus 4y power 10. How many terms are there? Three terms are there. It has only three terms. So this polynomial is called trinomial. Tri means three. Okay, my dear children, is it clear? Right. Now come to the next point, that is degree of a polynomial. We are going to discuss about the degree of a polynomial. The highest power of the variable, the highest power of the variable in a polynomial is called the degree of the polynomial. What is called the degree of the polynomial? The highest power of the variable in a polynomial is called the degree of the polynomial. The degree of a non-zero constant polynomial is 0. This is a particular case. The degree of a non-zero constant polynomial is 0, and the degree of the zero polynomial is not defined. We say that the degree of the zero polynomial is not defined. To understand this point, degree of a polynomial, let us take some examples. Okay, my dear children, see this first example. X power 5 minus x power 4 plus 3. What is the highest power of x here? 5. Highest power of x is 5. I wrote here highest power of the variable 5. So the degree of the polynomial is 5. Is it clear, my dear children? Right. Now come to the next second example. 2 minus y square minus y power 13 plus 2y power 5. What is the highest power of the variable? 13. Here the highest power of the variable is 13. So we call here the degree of the polynomial is 13. Is it clear, my dear children? Right. Now come to the third example. Minus 3 by 7. Minus 3 by 7. Is there variable in this polynomial? No variable is given here. So this is a non-zero constant polynomial. This is a non-zero constant polynomial. So the degree of this non-zero constant polynomial is 0. Okay. The highest power of the variable is here 0. Okay, my dear children. So the degree of this non-zero constant polynomial is 0. Is it clear, my dear children? Right. Now come to the next point, that is point number 7. Types or classification of polynomials based on the degree of a polynomial. This is another classification of polynomials. These are another types of polynomials. To understand this point, let us take some examples. See here, this is a polynomial 4x plus 5. What is the degree of the polynomial? 1. Here highest power of the variable x is 1. So the degree of the polynomial is 1. Then the polynomial is called linear polynomial. If the highest power of the variable is 1, then the polynomial is called linear polynomial. It has at most two terms. Remember these points, my dear children. A linear polynomial has at most two terms. And this is the general form of a linear polynomial. Ax plus b, comma, a is not equal to 0. Means x term and constant term. Only two terms. At most two terms. Is it clear, my dear children? Right. Now come to the next example. Minus x square plus 5x minus 3. What is the degree of the polynomial? 2. Because the highest power of the variable x is 2. So, if the degree of the polynomial is 2, then the polynomial is called quadratic polynomial. Remember these points, my dear children. Is it clear, my dear children? Right. The degree of the polynomial is 2. If the degree of a polynomial is 2, then what is the polynomial called? Quadratic polynomial. It has at most 3 terms. A quadratic polynomial has at most 3 terms. Now, this is the general form of a quadratic polynomial. What is the general form of a quadratic polynomial? Ax square plus bx plus c, where a is not equal to 0. If a is equal to 0, then this term vanishes. It disappear. So a should not be equal to 0. This is the general form of a quadratic polynomial. Is it clear, my dear children? Right. Now let us take another example. Minus 5 by 3x plus x cube minus x square. What is the degree of this polynomial? 3, because the highest power of the variable is 3. Therefore, degree of the polynomial is 3. If the degree of a polynomial is 3, then the polynomial is called cubic polynomial. If the degree of a polynomial is 3, what is the polynomial called? A cubic polynomial. It has at most 4 terms. A cubic polynomial has at most 4 terms. And come to this general form of a cubic polynomial, ax cube plus bx square plus cx plus d, comma, a is not equal to 0. This is called general form of a cubic polynomial. Is it clear, my dear children? Right. Now come to the next polynomial. Minus 1 by x square minus 7 by 8 x power 4. Then what is the degree of this polynomial? 4, because the highest power of the variable x is 4. So the degree of the polynomial is 4. If the degree of a polynomial is 4, then the polynomial is called biquadratic polynomial. If the degree of a polynomial is 4, what is the polynomial called? Biquadratic polynomial. It has at most 5 terms. A biquadratic polynomial has at most 5 terms. Now come to the general form of a biquadratic polynomial. Ax power 4 plus bx cube plus cx square plus dx plus e, comma, a is not equal to 0. This is the general form of a biquadratic polynomial. Is it clear, my dear children? Right. Now come to the next point, 8th point. This is the last point and the last concept for the exercise 2.1. General form of a polynomial of degree n. What is the general form of a polynomial of degree n? A polynomial in one variable x of degree n is an expression of the form an x power n plus an minus 1 x power n minus 1 plus an minus 2 x power n minus 2 plus and so on a2 x square plus a1 x plus a0. This is the general form of a polynomial in one variable x of degree n, where a0, a1, a2, a3 and so on an minus 2, an minus 1, an are constants. These are all constants, and an is not equal to 0. The coefficient of highest power of the variable is not equal to 0. It is a non-zero number. In particular, if an is equal to an minus 1 is equal to an minus 2 is equal to and so on, a3 is equal to a2 is equal to a1 is equal to a0 is equal to 0. It means all the constants are 0 in a polynomial. If all the coefficients are 0, we get 0 polynomial. Then what do we get? 0 polynomial, which is denoted by 0. 0 polynomial is denoted by 0. The degree of the 0 polynomial is not defined. Previously we have discussed this point, my dear children. Remember. Is it clear, my dear children? Right.